There are times when we need the application to solve a calculation involving values from certain attributes, constants, and/or functions. For these cases, GeneXus provides formulas. Formulas can be defined in two ways. Globally, the calculation will be available throughout the knowledge base, or also locally or inline. In this case, the calculation will be available only in the object in which it has been defined. Let's start by explaining what a global formula is and how it's defined. A global formula is a calculation defined in relation to an attribute. Note that transaction structures contain a column titled Formula. If a calculation is defined in this column for an attribute, GeneXus will understand that this attribute is virtual. That is to say, it will not have to be physically created as a field in the associated table because attribute value will be obtained by making the calculation we've indicated. Let's see this with an example. First, we will define a new attribute in the flight transaction in order to store the price of each flight. So, we add the flight price attribute, and we create the price domain. We save, and now we will add another new attribute in the same transaction to store the discount applied to each flight. We call it flight discount percentage. Its data type will be a domain also called percentage with a numeric of 3 digits. Lastly, we will add another attribute called flight final price. Which is based on the price domain, and this time, the attribute will be defined as a global formula. To this end, in this attribute's formula column, we will define the calculation necessary so that it's always run, and this attribute provides the flight's current price. That is to say, the price after subtracting the discount percentage stored in flight discount percentage from flight price. So, in this formula column, we will type the corresponding calculation. Note that in this window, we only have to type the calculation and not the assignment. Now we press F5, which automatically saves all pending actions, and we see what happens. In the flight physical table, only 2 fields are created, even though we've defined 3 new attributes in the transaction structure. Due to the fact that the formula column contains a definition, this attribute is not added in the physical table. Because the attribute is defined in the knowledge base with an associated formula, GeneXus can calculate its value. Also, in every object where this attribute is included, the calculation will be made and the results will be shown. We reorganize, and we see the application at runtime. We run the flight transaction, query flight number 1, and in this form, we see the 3 new attributes created. The flight price enabled for us to enter it, the discount percentage also enabled for us to enter it, and the final price disabled because it's the attribute defined as a formula and its value is not entered. Instead, it'll be calculated and displayed. Every attribute defined as a global formula will be read-only, and it will not be possible to enter a value for it. This happens because the attribute obtains its value from the associated calculation, which is run every time the attribute is used. For this reason, there isn't a field in the physical table to store this attribute value. For this reason, there's no need for it to be editable. We will enter a price for this flight, let's say 1500, and a discount percentage, 10%. After leaving the field, we see that the formula is immediately run, and the final price of the flight is displayed with the discount applied. Let's return to GeneXus. In this way, we've defined a global formula attribute. Only attributes can be defined as global formulas in the way we've seen, using the formula column in the transaction. Something important to remember is that even though in the example we've only used attributes from the transaction's own associated table, that is to say, its base table, attributes from the extended table can also be used. Let's see it. We will create a new transaction called airline to record the airlines. So we type airline ID, airline name, and airline discount percentage to record the discount made by the airline for all its flights. We save. Now we open the flight transaction to assign an airline to every flight. So we add the airline ID attribute, which here will be a foreign key, and change the value of its nullable property to yes. In this way, we can avoid indicating the flight's airline at this stage because we still don't have any airlines recorded. Later on, we can change again the value of this nullable property to no, so that it's mandatory to indicate the airline when entering or changing the details of a flight. In addition, we add the attributes airline name and airline discount percentage to also view the data in this form. Now we will change the definition of this formula to have it calculate the final price of the flight by applying it the generic discount of the airline instead of applying the discount of the flight itself. And we press F5. As we can see, the airline physical table will be created with the three attributes defined, and in the flight table, the airline ID foreign key will be created. So we reorganize and run. We run the airline transaction and enter an airline, called TAM, with a 30% discount. Now we will assign this airline to a flight. So we open the flight transaction, flight number 1, and associate it with airline number 1. The new final price of the flight, which is a global formula attribute, is calculated. And now it involves the discount percentage of the airline, which is an attribute of the extended table of the flight base table. We haven't mentioned yet that formulas can evaluate conditions, and the result can be calculated in different ways depending on whether these conditions are true or false. Let's see this. To do so, we click on this button to edit the formula. And we define that the highest discount percentage must be taken into account to calculate the final price of the flight in order to make the best discount possible. With this definition, if the airline has a higher discount for all its flights than the discount percentage of the flight itself, the airline discount will be considered to make the calculation. Otherwise, the discount percentage of the flight itself is used to make the calculation. Note that formulas are written as expressions, so they end with a semicolon. To calculate the formula, GeneXus keeps the first expression that meets the condition. If no condition is met, and an otherwise clause has been added, it uses this one. Let's move the final price attribute to the end of the list, so that the information is more clearly organized. We press F5, and we run the flight transaction. In the first flight, we set its discount percentage to be higher than the overall discount percentage of the airline. For example, let's say 50%. We exit this field and go to the airline field, so that it has everything necessary to calculate the formula. The final price of the flight was calculated using the highest discount. Let's return to GeneXus. As we've seen, Formulas can contain several lines followed by if, and may contain a last line with otherwise in case none of the above conditions are met. In turn, even though in this example each result is obtained through a calculation, functions applied to attributes or expressions can also be used, such as round, to obtain a rounded result. Also, month can be used to obtain the month of a date, and so on. Even a user-defined procedure can be called to return a value. If we right-click on the formula editing dialog and choose the function option, a new dialog will be displayed showing all the functions we could insert. Let's go to the GeneXus wiki to search for information about this. At wiki.genexus.com, in the search box, we type functions. Several entries are displayed with information about what we're looking for. For example, if we click on Functions in Transactions, we'll see all the functions that we can use in transactions, and if we click on any of them, we'll get their complete information: use, syntax, types of data returned, examples, and so on. Now let's look at the Object Functions entry. It explains how to access the functions corresponding to a certain object in which we're positioned, and gives an example that uses the month function to obtain the list of clients who have a birthday in the current month. The entry Methods and Functions Matching shows functions that have a method with the same meaning and behavior. We've already used the isEmpty method to control whether a field is empty, but there are many others that we invite you to explore. Formulas of this type, which make a calculation obtained from the data of the record in which we're positioned, just one, and occasionally of the associated records, through the extended table, are usually called horizontal formulas. Now we will see another type of formula called aggregate formulas. We will explain them by defining examples of global formulas, that is to say, the corresponding calculations will be defined in relation to attributes, and therefore they will not be created as physical fields. As a result, our examples can also be assigned in another context, such as a variable, for example. They may also be assigned locally in a certain section of an object. We will see this in another video. Now we will create a second level in the flight transaction, and we'll call it seat. As described by this level name, we will use it to record the seats available in the flight. For each seat, we will indicate if it's next to a window, an aisle, or in the middle. Next, we will need to know the total number of seats available in the flight. We type a period and complete the attribute name, flight, seat, ID. And now we create another attribute called flight seat location. It'll be a character of 1. Now we edit the domains to change a property of the location domain that we've just created. We locate the enum values property and define the 3 values that this domain can take. Window, the character stored in this case will be W. Middle, the character stored in this case will be M. Or aisle, the character stored in this case will be A. We click on OK. Look at the form of the flight transaction. A grid has been added to enter the flight seats, and for every seat, we can indicate its position through a combo control. This combo offers the values window, middle, or aisle because they are the possible values defined for the domain of the flight seat location attribute. Before pressing F5, let's look at the definition of the second level. If the key is made up of flight ID plus seat ID, for each flight, the seat numbers cannot be repeated. However, we need the seat number to be repeated because it's identified by this number and a letter. In this way, we will have seats 1A, 1B, 1C, 2A, 2B, and so on. So we add a new attribute, flight seat char, and its domain will be seat char with a character of 1. We will make this attribute part of the key to record the same seat numbers with different letters. We will limit the possible letters from A to F, and to do so, we will edit the seat char domain that we've just created. We locate its enum values property and define the possible values. In this case, the description's values match the values stored. We click on OK. Now, to find out the maximum number of passengers allowed on a flight, according to the number of seats, we will define a new attribute in the first level. In its formula column, we will indicate the calculation consisting in counting the number of seats offered in the flight. So, we create the attribute, flight capacity, and its data type will be numeric of 4. In its formula column, we type count, and between brackets, we add an attribute that lets GeneXus know that we want to count the seats. To this end, we choose the flight seat location attribute that belongs to the transaction level containing the seats. The count formula will count data in memory or records of a table depending on the case. If we're inserting or updating a flight, the count formula will count in memory the seats that the user has been recording. If the end user is not interacting with the transaction form, the count formula will count the records in the flight seat table. If we're positioned on a given flight, GeneXus will only count the seats corresponding to that flight. That is to say, GeneXus automatically detects the relationship between the table where the formula attribute was defined and the table navigated by the formula. So, to perform the calculation, it'll only take into account the related records. If no relationship is found, GeneXus will count all the records of the table navigated. The attribute that's referred to inside the brackets of the formula gives GeneXus information about the level in memory that must be run through, or of the table that must be navigated to perform the calculation. Let's try this at runtime by pressing F5. As we can see, the flight seat physical table will be created and it will be associated with the second level of the flight transaction. Also, it will contain the attributes and the key that we've defined. Note that the structure of the flight transaction will not be modified because the flight capacity attribute will not be physically created as we expected. We agree, so we click on Reorganize. We run the flight transaction, query flight number 1, and enter some seats. 1A, window, 1B, middle, 1C, aisle, 1D, window, 1E, middle, and 1E, aisle. As we enter the seats, note that the total number of seats is updated every time we add a new seat to the flight. That is to say, it's triggered interactively in the browser as we add lines, and when we leave the attribute mentioned in the count. Go back a little bit in this video, and look at what happened with the formula attribute. Lastly, we add 2a window, and we'll stop here. Let's return to GeneXus. In addition, there are other aggregate formulas that make operations by taking several records into account. For example, sum to add the values of the specified attribute, average to find the average value of the specified attribute, and others such as max to find the maximum value of an attribute in the table to be navigated, and return the value of some other attribute for the corresponding records. Min to do the same but with a minimum value, or find to find the value of an attribute according to some condition. For example, to find the identifier value of an attraction whose name is Eiffel Tower. This will be frequently used later. If we want to count not only the total seats in the flight we're positioned in, but also those that meet another condition, such as, for example, the number of seats next to the window, we can add this condition to the formula. In this way, since the flight seat location attribute belongs to the location domain, and it has 3 enumerated values defined, the syntax to ask for the value taken by the attribute is as follows. Domain name, period, and the name associated with the value we want to filter by, which in this case is window. We click on OK, and we press F5. We run the flight transaction, record number 1, and the flight's capacity is now 3, and it corresponds to the number of seats located next to a window, which matches the seats we entered in the seat grid. In sum, we've seen that in addition to the implicit condition, when there are related records, it is also possible to count, sum, search for, maximize, or average. That is to say, add those records that comply with a certain explicit condition indicated by us. This condition is called filtering condition because it allows us to keep only those records that we're interested in. Lastly, we must remember that just like every other global formula, aggregate formulas can have a triggering condition. That is to say, the formula is only calculated when this condition is met. In sum, we've seen 2 types of formulas. Horizontal formulas, they access a record to make a calculation. Also, these records may be related through the extended table. That was the case of flight final price. These attributes belong to the flight table, and the others to the airline table. As we saw in the example, we could set a formula attribute to be calculated in different ways depending on the value of a condition. We also saw aggregate formulas. To make their calculation, they need to navigate many records in the same table. That was the case of flight capacity. From the flight table associated with the formula attribute, it made a calculation over the flight seat table that contains the flight seat location attribute. In this case, since the formula attribute is associated with the table, flight, which has a one-to-many relationship with the table over which the count operation will be made, only the related records will be counted. If the relationship didn't exist, they would all be counted. In addition, because we indicate conditions for the records to be counted, the related records will only be counted as long as they meet that condition. The filtering condition is the second parameter in the formula, and as a third parameter, we can indicate a default value. That is to say, the value that will be returned by the formula if no record is found to count, sum, and so on. Just like horizontal formulas, aggregate formulas can be stated with conditions. Also, horizontal formulas can be combined with aggregate formulas, providing a high degree of expressiveness in calculations. But we won't talk about that in this course. An aggregate formula can not only be specified if the table being navigated corresponds to a level of the same transaction. In the example we saw, the formula attribute, flight capacity, is on the first level of the flight transaction, and the table being navigated will be the one corresponding to the second level. But let's look at what would happen if, for example, we wanted to define a formula at the airline level, airline flight most expensive ID, that would return the flight identifier of the most expensive airline flight. The formula we need in that case is max. If we look it up in the wiki, we see that it has 4 parameters, of which only the first one, that indicates the value that will be maximized, is mandatory. In our case, it would be defined in this way: max, flight final price, empty empty, and flight ID. Where we are, of all the flight records corresponding to the airline, keeping the one or the ones with the highest flight final price attribute value, it doesn't matter that it's also a formula attribute. And for the first of the maximum price records, it returns the value of the flight ID attribute. Since we didn't specify a second parameter, it will not apply any other filter condition on the records to be considered for maximization. And, since we didn't include a third parameter, if it doesn't find any associated record, it'll return the empty value. But this will only happen if the airline does not have any associated flights. If we see it running, when we open the airline transaction, the formula is triggered, which will navigate the flight table, which is not in memory at this time. Lastly, let's remove the filtering condition from the flight capacity attribute. And we'll send the new definitions to GeneXus server. The formulas discussed in this video are those specified at the attribute level. They're called formula attributes and are known throughout the knowledge base. Later on, we'll study the others, which are equal but not assigned to an attribute. They're the so-called local or inline formulas. Remember that formula attributes are virtual. In other words, they're not physically created as fields in the associated table. However, it is possible to modify the default behavior of these attributes and store their values, defining them as redundant attributes so that they will no longer be virtual. We invite you to read about how to do this in the GeneXus wiki. Remember that aggregation formulas don't always need to search for information in a table, but they also, as in the case of a flight that we studied, operate in memory. Watch the next videos to learn how to use local or inline formulas.